To continue our discussion, we're going to go talk about exponential functions. We're going to do differentiation and integration. Let's do a review. Let's go look at that toolbox again. Properties of the natural exponential function. Definition. The inverse function of the natural log function, f of x equals ln x, is the natural exponential function and it's denoted by f inverse of x equals what? E to the x. Okay, note y equals e to the x if and only if x equals ln y. When you're given this, how do you solve for x? You have y equals e to the x. You take the natural log of both sides. Ln y equals ln of e to the x. That x walks out front and becomes x times ln e, and ln e is 1. Okay. Inverse relationship. Ln of e to the x equals, what did I just say? X. And e to the ln of x equals x. Exponential and log are inverses. They undo each other. What one does, the other one undoes. So starting here, if I take x and I exponentiate it first, and then I take the natural log, I get back just x. Okay, properties of the natural exponential function. What's the domain? Do you remember? Should we go graph it first before we look at domain and range? Okay, it's an exponential, so our three favorite x's are -1, 0, and 1. E to the -1 is 1 over e, which is about 0.37. E to the 0 is 1. E to the 1 is e, and that's about 2.71828, so 2.72. Go plot those. I have -1.37, 0, 1, and 1e. Exponential growth. What is the domain? What x values can I plug in? All real numbers. In interval notation, it's -infinity to infinity. What about the range? What y values do I get back? Do I get 0 though? Anything bigger than 0. So how do we say that? Parenthesis 0 to infinity. Remember that infinity and -infinity, you always use parentheses when you're doing interval notation. If you want to include the number, you use a bracket. Okay, this function is continuous, it's increasing, and it's 1 to 1. Do you see that? Continuous meaning you never pick your pencil up when you draw it. Actually, that's the informal definition. It's increasing. I could check that by doing the first derivative test, and you would find out the first derivative is always positive. And it's 1 to 1. It passes what test? Horizontal line test. Okay, that function is also concave up, meaning the second derivative would always be positive. What's the limit as x approaches -infinity? Way out here, what's the y value doing? It's going to 0. What's the limit as x approaches positive infinity? So way out here, what's the y value doing? It's blowing up. that limit actually does not exist, right? But we can say why it doesn't exist. It doesn't exist because it's going towards infinity. All right. Next page. Derivatives of the natural exponential function. This is huge. It's in red. Let u be a differentiable function of x. If your function is y equals e to the x, your derivative is e to the x. Kind of boring. Very boring. If y equals e to a function of x, like e to the u, then your derivative is going to be e to the u, and then you've got your chain rule times u prime. So if your function is y equals e to the blah, your derivative is e to the blah times d blah. All right, lots of examples. Find the derivative of y equals e to the 3x. Y prime will be, rewrite it, e to the 3x times 3. Now if you want to clean that up and say 3e to the 3x, you go for it. What if y equals e to the square root of x? You're going to have e to the square root of x times. All right, over to the side. If I have square root of x, I want to rewrite that as x to the 1/2 power. When I take the derivative will be 1/2 x to the negative 1/2. So that becomes 1 over 2 square root x, yes? So I get 1 over 2 square root x. If you want to rewrite that as e to the root x over 2 square root x, you go for it. Questions on that? Let me pause for a second. Number 3, y equals cosine of e to the pi x. We've got a chain rule going on here, right? You've got cosine of blah. How do you take the derivative of cosine blah? It's negative sine of blah. Now I have to do times the derivative of blah. How do I do the derivative of that? I say e to the pi x times the derivative of that. So times, what's the derivative of pi x? Pi. And you're done. I would rewrite that as negative pi e to the pi x sine of e to the pi x. But my eye, when I'm grading your test, my eye is going to probably be looking for that. Okay, doing the product rule, because I have x times e to the negative x. Product rule says, take the first one, multiply it by the derivative of the second one. What's the derivative of e to the negative x? E negative x times negative 1 plus the second one, e to the negative x, times the derivative of the first. What's the derivative of x? 1. So I get negative x e to the negative x plus e to the negative x. I would probably choose to factor out an e to the negative x, and I would get negative x plus 1, because usually when you take a derivative, you're going to set it equal to 0, solve for x, like if you were trying to analyze the graph, and you would get a critical point of 1. Anyway, this is good with me for a test. Leave it be. Simplify if you can. I would prefer to see that. if it were a multiple choice question and this were the answer, you would have to work with it a little bit. All right, number 5. How would I find the derivative? I see x's and y's in there together. That tool that you need to reach back behind you and grab out of your toolbox, implicit differentiation. Anytime you take the derivative of a y, you have to say times dy dx. I'm going to give you a minute to try it first. All right, number 5, when you take the derivative, you're going to have to do it implicitly. The derivative of e to the blah is e to the blah times the derivative of blah. How do you do the derivative of x times y? You're going to have to do the product rule on that one, which says do the first, which was x, derivative of the second. What's the derivative of y? It's 1 times y prime. Some of you just say y prime, that's fine. Plus the second, which is y, times the derivative of the first. What's the derivative of x? It's 1. Okay, then I have plus. What's the derivative of x squared? 2x. Minus, what's the derivative of y squared? 2y dy dx, or I'm going to just write 2y y prime, equals, what's the derivative of 10? 0. So I'm going to go distribute this e to the x term first, or sorry, e to the xy term. I get x e to the xy y prime plus y e to the xy plus 2x minus 2y y prime. Okay, do you see that I have two things that have a y prime in it? I'm going to keep those on the left-hand side of the equal sign and get the other stuff, so this, get that to the right-hand side. X e to the xy y prime minus 2y y prime equals negative 2x minus y e to the xy. Now what do I need to do? Factor out a y prime. So I can go like this. And then I'm going to divide both sides by this stuff. So divided by x e to the xy minus 2y. There's your derivative. Questions? Integrals of the natural exponential function. Theorem. Let u be a differentiable function of x. How do you integrate e to the x dx? The integral of e to the x dx is e to the x plus c. What's the integral of e to the u du going to be? E to the u plus c. So 2 examples. Go integrate e to the 2x minus 1 dx. I'm going to give you time to think. Doing an old-fashioned u sub, what is your u going to be? 2x minus 1. What's du? 2 dx, right? Do I see a 2 dx in my problem? No, but if I put a 2 here, I need to put a 1/2 out front. Now I see du. So my problem becomes 1/2 integral of e to the u du. How do I integrate e to the u du? It's e to the u plus c. So I get 1/2 e to the u plus c. Do I want to leave it with u's? I want to go back to x's, so I get 1/2 e to the 2x minus 1 plus c. You're finished. Number 2. Integrate the definite integral from 0 to 1 of x e to the negative x squared dx. At first, treat it like it's an indefinite integral. If I treat it like an indefinite integral, right now I'm going to erase those two. What's my u? Negative x squared. What's my du? Negative 2x dx. So I need to stick in a negative 2 there and a negative 1/2 out front. Yes? This becomes du. So I'm looking at integrating negative 1/2 integral. Well, that's just e to the u du, yes? So I get negative 1/2 e to the u plus c, which is negative 1/2 e to the negative x squared plus c. Now my problem was the definite integral from 0 to 1 of x e to the negative x squared dx. The indefinite integral, the answer was negative 1/2 e to the negative x squared. Now instead of writing plus c, I'm going to write from 0 to 1, exactly. Now what do I plug in first for x? Do the top. So I get negative 1/2 e to the negative 1 squared minus negative 1/2 e to the negative 0 squared. Definite. What happens to the plus c in a definite integral? It's gone. It poofs. Only with indefinite integrals do you have a plus c. Definite integrals, you're going to end up with a number. No plus c's. Okay, so I get negative 1/2 e to the negative 1 plus 1/2 e to the 0. What's e to the 0? 1. So I get negative 1 over 2e plus 1/2. I'd leave it. Questions?